Semantic Primes and Semantic Metalanguage. Part of all human languages, as I say, original work was in 70 something. It's been worked on for over 30 years, loads of papers about it. One of the interesting things about it, well, the natural semantic metalanguage bit of it, which I'll show you in the next couple of slides, is that it gives a set of phrases. There are about 150 phrases, which sort of describe how words are used or what they depend on, their context. So those scripts, 150 or so, doesn't seem that much effort, for the potential reward. If you were going to want to try and pursue that as a bootstrap. Anyway, the thing about the semantic primes that struck me about them is that essentially they seem to be about properties of human experience or human self-awareness, which, when you look at the list of them, these are the you can't actually read it. Oh, no, actually you can read those pretty well. We've got an enormous screen here, haven't we? So, I can read those. Maybe you can't from the back, but yeah, okay. All right. Yeah, so if you look at those, are there any that you believe that you've ever actually explained to a young child or actually needed to, words like payslip? What's a payslip, Daddy? What's that in your head? Payslip is a molecule type word, because it's a whole bunch of other concepts that are stuck together. These are the base of the inverted, these are at the pyramid tip, the inverted pyramid tip of language.
You still have to learn.
No, you have to learn what we're seeing here. If you think of them not as English words, but concepts that are universal to all language. I mean, they're written here in English, but these are universal concepts that, do you think that you would have been able to understand them before you had the label for them? Like, the concept of kind or part. Yeah.
There isn't words you were learning the label for that.
Yes, yeah. So the language acquisition is about the process of labelling stuff, and when you get back to these very core early words, these, because we have awareness of self, social awareness, awareness of the environment. At some point, in the conscious mind of a child, all of this stuff could be known just intuitively from the experience of being human, without actually having words for it.
Aren't we missing something on those? If you take something like one, two, and many, there's kind of an induction there as well. There's a process there. So then maybe out of that we might be missing a process. So if you explain it to a kid, you say one, two, many.
Yeah. Yeah. Then.
And many, in which case many isn't fundamental.
There are some details.
Yeah, okay.
In that, I think that there's true listed, but or there's not. But I wasn't sure that there was false. But then you've got not true.
Yeah.
So, yeah, there's some steps, as it were. But it occurred to me that there's an opportunity there. Looking at it from the computer science hat wearer, thinking, yeah, I could do something with that. That's some data, as it were. So, okay. So this is the natural semantic metalanguage. You can't read that very well, can you? But yeah, it's an A4 of phrases. I'm not sure this is the full set, but apparently there are about 150. It could be the full set. I don't know. original works on this area come in 2 volumes, and they're about 100 quid each. So, and I'm not a member of a library, university library, so I've not been able to read them. But from the bits I've been able to grab off the web, I think I've learned enough to think, yeah, I could do something with that. That's an opportunity. So, as an example, as I described, the meanings imply a possible usage grammar. Their context implies dependencies and actions and so on. So, I mentioned this. I like this as something, as an example, as being different to that or those or them. All humans need those words for the kinds of interactions that we have with those words. But also, we've got this someone, this something. Someone is a bit more complicated. I started trying to model that, but it's possible. So there's a whole raft of stuff there, and I'd need some help with a linguist from some of the detail of this stuff, because I'm sure I'm going to miss some of the subtleties of the classes of things that this connects to from a language point of view. But to me, each example is like a context with sort of a stickiness. I'm sort of looking at it as a stickly brick type thing, with a front end and a back end of stuff that you can plug it into, as it were. And if you've got a generic model of some objects, software people doing this kind of thing, we can have the interface, the class that is able to connect to this as an outcome. And there's some more. So in recognising them, it teaches an associated grammar, a universal grammar. You can see that would be there. So how can you do this? Well, you can do it. More research is needed. I've started doing some of this, but I'm not full-time on this, unfortunately. But if you put this into a computer, there would be big opportunities, I think. So, mentioned semantic molecules. They're things that are definable exclusively with semantic primes. Now, they claim to be this whole thing claims to be universal. So how do you test whether or not a set of words are a universal opportunity in language use, as it were? Well, in a study, they got a bunch of students to pick 1,000 words out of it's actually the Longman's English Dictionary at random, and worked on producing semantic prime-based definitions of those. Now, it's quite irritating when you look in a dictionary along some words that a definition will bounce off another definition, which will bounce back to the same definition, and it doesn't actually tell you anything at all. Well, using this semantic prime approach of atoms going into molecules of words, they were able to produce a dictionary definition that actually worked properly, from basic principles. And they reckoned that 1,000 examples was good enough. Also, I've actually lost the reference, but I'm sure I came across a reference of how they translated one of the works of Plato, which is extremely erudite and complicated and difficult to get your head around. But they were able to convert that into semantic metalanguage without any loss of information. Well, that seems like pretty good proof that this is a good thing. So the molecules are proposed to be universal, as some are proved to be universal in this list, and there are others that are more cultural. Apparently, there's cultural influence that English is spreading across the world when language is studied, apparently. I wasn't aware of, but there you are. So, yeah, some molecules will be culture specific, some will be topic specific, obviously. Anyway, it all sounds doable. What are the molecules? Well, things like, the obvious things: hands, mouth, ears, physical attributes, so the body parts, physical attributes, long, round, flat, thin. These are apparently all things that you can define with the semantic primes, so they're not atomic, but these are still those sort of low-level sensory type experiences that you need the basics in order to communicate. Biosocial, children, men, women, so on. So kind of what you'd expect to need in conversation. So how are you going to move on to representing words in a computer? Well, you need to define a possible word usage, as it were, like a template, and then there will be a word object instance, and actually relate that word object instance inside an instance of a simulated world. And then if you were able to share that simulated world with a robotic mind and a human mind, you would have the ability to share that common context, that common experience. And then you would then able to observe or discuss, as it were, relate to common outcomes, common actions. You'd be explaining stuff to each other because you've got a language in common. So that relies on, when you model that word object instance, the dependencies, the this or up or whatever. I mean, up is a difficult one to describe. The opposite direction of gravity, or the direction that I point my head when I tilt it backwards. Dictionary definition, completely meaningless, but we all know what it means. Anyway, recognisable world context. I've just described up. You could describe that in a computer easily enough. It would take some effort, but we've got sensors that do that kind of stuff. Sorry, I can see you.
No, I was just wondering if you thought there was going to be any additional difficulties, because a lot of those primes are very human-specific,
Yes.
as you mentioned there. Do you think there'll be any difficulties with a non-embodied intelligence, non-human embodied intelligence, understanding these primes?
I think my view of it is that in order to get a non-embodied intelligence, the intelligence that non-embodied intelligence has to get needs to have gone through an embodied intelligence, or an intelligence that has a virtual embodiment. Yeah, because this is why the internet isn't like the Star Trek computer, where the Star Trek computer says, "Did you really mean that?" or "Can you clarify?" Or because we get a list of Google hits rather than which are guesses rather than actual understanding, because it hasn't got the physical experience that all of us have got.
We don't have a shared experience.
Yeah, sure. So all right. So then I sort of went off a bit of a tangent, really, and the answer to this again comes back to, hang on, it's simulation again that we're needing for the AGI, the advanced general intelligence, the human-like intelligence. Because where might we be for wanting an embodied intelligent robot? Well, if you think about there you are on the Mars colony that Elon Musk has managed to put together for us all, which won't that be nice? Unless it comes out like total recall, of course. But he's hoping that people are tolerant and accepting and don't create slavery and stuff. Anyway, you're the head of this colony, and you ask your head robot to build you a new greenhouse because you've got some more settlers coming and you need some more veg. You can see that being needed. So the robot comes back and says, "Yeah, we can do that, but we're going to run out of cement," because the robot knows what stuff is in stock and what is involved in getting the plan executed. And the robot is also connected to the survey of the archaeology of Mars, and therefore knows that 200 miles away there's a pile of rocks that are there to be mined as an opportunity. And so has worked out that with a couple of robot chums and a transporter, it can be sorted out. But this is a plan that the robot's managed to come up with a solution to this particular problem and wants to discuss it in the future, and helps to book you a meeting in the future when you're free, so that you can decide whether or not it's a good idea or not. Sci-fi, I know, but actually having a team of articulate robots when you're up on Mars and there's no atmosphere outside and things are going wrong and you need someone to go out and fix stuff, having a team of skilled robots behind you would be a very good thing. Because if you're going to go out there and spacewalk, you're going to get very tired and perhaps not be able to fix whatever horrendous problems are going on. So, sci-fi, but might be what we ultimately want. So, what do we want to be able to do? Be able to do multiple tasks, build complex tasks from simpler actions, pause what a robot is doing, save where we are on a task, do some other task. Yeah, I started decapitalising everything, and I see actually I didn't manage to get very far, so apologies there. I meant to. I had a style change part way through.
I wondered if it was because the robot was speaking in primes or...
Yeah, I got part of the way through adjusting this, and then somebody says, oh, it looks so 1980s, which I don't actually know what that means, but I thought, well, whatever, no, I'll change the style. But anyway, I did an incomplete job. So, in effect, to recall an incomplete task, because you've gone off and done something else, and then you're coming back to something that you've got part of the way through, and actually then you decided, well, I'm not going to complete that at all. I'm not bothered by that, so I'll scrap that task, don't need to remember about that, and I'll move on. So you need the capacity to do all of that kind of stuff, and you need to be able to load and understand a new task that is based on a similar task. So it's all about simulation and saving of data to disk and reloading it, and modelling of stuff and concatenating those things together and being able to pause your simulation of whatever the task was that you're doing. Yeah, so simulation again. Again, we're going to get on a bit more to simulation. The biggie that people argue about is defining time. Well, if you ask people, give me a definition of time, and their sort of mouth will drop open and think, well, that's hard. I don't know really. Well, the reason for that is that time is a pre-verbal concept. We haven't actually had time explained to us verbally what it is. We experience time. We know what it is. But it's not part of everyday discussion. So if you try to describe it with events, with something called discrete event simulation, this is where we're heading, it's actually quite easy to understand, in that discrete event simulation is a type of software tool where you have a state known as the current time, and that's where events can occur now at current time. So there's a list of events that it knows are likely to happen in the future. When the future has come, as it were, you don't actually have to wait for the future, because you fast forward to the future to execute your list of 1 events or 10 events or whatever. So you can simulate stuff very quickly. But the thing is the generation of the events, your predictions of what's going to occur in the future. So events, their outcomes are defined at current time, and in the future we've got scheduled events and possible future outcomes. But in the past we still have knowledge of events, but they're now fixed, they're now constant, and their outcomes have occurred. They may have left an impression on the current state or the past state of the world by their outcome, may or may not. but whether there's any evidence of that event having occurred or not, we have the history, the knowledge of the fact that it did occur in the past, and we can't change it because it's a constant, because it's in the past. Well, that's time, isn't it? Although we can't, it's a long-winded way of explaining it. So the future events, these are outcomes that could, might, should, will not, cannot, may happen. So, there's lots of sort of phrases that we can model about as computer people to, as I'll move on actually, it's in the machine learning world, it's done described like a Bayesian network, isn't it? That's for the mathematical people here. Machine, got a nod there. This is what people in other spheres are describing, but they use different terminology for the same thing. This is quite important. Simulation events must be processed independent of one another in discrete event simulation. That's an important thing to remember. I'll mention that a bit later. Now, if you're not a computer person, this is going to look scary, but it's something called UML, Universal Modeling Language. And it gives you the opportunity of being able to relate one thing to another. There's a whole different scheme of diagrams of things. Well, in the linguistic world, there's sort of a mystery as to how the words of subject, object, and verb are organised, and how humans learn what these things are. The subject description actually, in some languages they call that the actor, which actually makes more sense, because the actor is the person who does the verb, the thing that does the verb. So if we were talking in Basque, rather than calling it a subject, which doesn't make much sense, we'd be talking about the actor. Well, that makes more sense, because it's the actor's the person who picks up the hammer to hammer something, which is the nail, that is the object of the sentence. So that's how, we in English we would say subject or actor, I, hammer, verb, nail, object, because that's in English how words are arranged. If I was speaking in German, the verb would go at the end, which seems very confusing to me. Maybe if you're German it doesn't, because actually knowing what's, my brain is wired to work in the English way. So there's a bit of a design looking at how we've got a view of our true self, and we've got multiple my views into things, which can be my view into my imagination, or my view into multiple worlds. So, I've got one view, as it were, that I'm maintaining, but I can have multiple views into imagination, or multiple views into a virtual world experience, because I'm a robot, that's all I've got. And I don't have a human mind's eye, I've got the equivalent of a virtual world. So when I'm having that my view experience in the world, if I'm on the acting end, the actor end of doing stuff, then I'm the I, I'm the subject. So when you're talking and you're experiencing language, you can start to realise, that wherever the order is in a sentence, the word that is me, that if that comes last or first or whatever, I'm learning the grammar of I and you and me, as in I'm going to do something, me, something's being done to me, you, as in I'm doing something to you. When you're talking about you doing something, you talk of I, so I have to shift my mind's concept to the fact that in your world you're experiencing I. So in order for me to understand language, I have to have my simulated mind world to appreciate the fact that when you talk, you say I, but you're not actually talking for me, I. you're actually talking for you. Yeah. So there's a whole level of layers and complexity and stuff that's going on inside a baby's head naturally. You know, the baby's able, the baby's able to naturally experience this, and people who write software, layered software architecture, multiple processes, it can all be done. It's very complicated, but this is some of the technology that is used in order to figure out the words that implement I. There could be multiple ones that implement I, and how those relate to being a subject. Anyway, there's a tool, GenMy model, which I've been using, and I'll grant this as open source. Right. How are people doing? Are people wanting a pause now for more drinks and questions, or am I okay to carry on? Yeah, carry on. Okay, right. So, we've been talking about words can be like something's called a Skinner box. He was a psychologist. Yeah. So they have a situational context. So when we wander into a room, we recognise a particular situation. We'll label that situation with stuff, and that if it's a this or whatever, and we know that we can potentially get an outcome from that context. So if we look here at what a Skinner box is as you see this rat, what it's doing. I mean, it's not being treated in any cruel manner in this experiment. Is it knows that it's going to get fed when that light comes on, and it pushes the little lever. The light comes on, and then it gets fed. But it needs to wait for the light to go out. It would need to learn a bit more. This rat. So once the light has gone out, it's actually worth it pressing the button, and then it gets fed. So it's recognising the opportunity that it's in, and taking a corresponding action. So this is how sort of I see words working in the physical world, as it were. Anyway, a bit more about simulation. I used to work for a company called Lana Group, and they have this discrete event simulation software. So this is about what they do. This is very much a I might leave the sound on for a while, actually. As you can see, this is very sales pitchy. Actually, so I can turn the sound off, actually. I might go back a bit. And actually point out the interesting things. We'll actually look at more the technology of what's going on. So this is their sort of desktop thing where they're looking at factories and the stuff that goes on inside factories, and you see these things that are moving into the factories. And now, they're talking about you're able to model stuff in 3D. They have a system of being able to model things in 3D. They'll model your entire factory in 3D if you want, or just 2D. But what they're able to do is define these, what they called simulation elements, which in effect are what we want, for our AI to describe the real world, as it were. We want to be able to describe simulation elements. Well, the way that Lana's described simulation elements is they've got an XML standard for it. It's a script textual theme, that they're able to lasso a bunch of stuff and describe its behaviour, and then be able to use that kind of as a template to describe an instance in the space that they're describing in the virtual world. They start off by doing all this flexible modular modelling objects, and this is the kinds of things that they do. So they analyse the outcomes of stuff based on all kinds of machine learning type maths, and compare choices so that you can do what if analysis of if you change the model slightly and gave additional capacity to something, or try doing something in a different way, you can see that there's different outcomes possible. Yeah, so that's an existing technology which, if you were able to do what was required. This is a bit of a slower pace thing. You see here that they're tabbing along on the various tabs of the simulation elements, and some of these are built in, or some of them are custom made. So it looks rather clunky actually. This what they're doing here. So they're dragging apart on. You can think of a part actually as being like a thread of control, like an idea or something that if you're following an outcome, you could use that concept for, and if you're persuading somebody in a conversation, you can see how that would travel